Hello everyone. Today we will discuss key points about aluminum die casting design. Whether you are an engineer, designer, or just curious, these insights should help. What's the best wall thickness for aluminum die casting? Wall thickness is very important in die casting. If it's too thin, the metal may cool too quickly, which can lead to incomplete filling. If it's too thick, shrinkage defects may occur. Keep walls even, usually between 2 mm to 4 mm, and avoid sudden thickness changes. If needed, use gradual transition to prevent defects. Die casting and CNC machining, which is more cost-effective? It depends on production volume. Die casting has high upfront cost, but it is cheaper for larger volume since it can produce thousands of matching parts quickly. CNC machining is better for small batches or prototypes. The cost for die castings varies, but generally for mass production, die casting is usually more cost-effective. Which aluminum alloys are best for die castings? Common alloys include A380, A383, and A413. These alloys offer good fluidity, strength, and resistance to corrosion. They have more silicon, typically 5% to 10%, than pure aluminum, which improves castability and reduces shrinkage. Choosing the right alloy is the key for high-performance parts. Why do die casting parts need a draft angle? Draft angles help remove parts from mold. Without them, parts can stick, damaging the mold or the part. 1 to 2 degree draft angle is usually enough for a smooth injection. It also reduces mold wear and improves the part's surface. Are casted aluminum parts as strong as machine parts? It depends on the design and use. Machine parts are often stronger because they have a more controlled grain structure. Cast parts may have more porosity and varying grain structure due to cooling differences. However, with the right design, alloy choice, and process control, die cast parts can be strong and durable, sometimes eliminating the need for machining. What do eject pins do in die casting? Eject pins help push the part out of the mold, but can leave small marks on the surface. Their placement is important. If they are not in the right spot, they can damage thin walls or cause defects. Designer must consider where the pins go when defining critical surfaces and tolerances. Why are undercuts a challenge in aluminum die casting? Undercuts make die casting more complex and expensive. They make parts harder to eject, requiring special mold features like slides or extra machining. This increases costs and production time. Avoided undercuts can simplify the processes and lower costs. How does silicon in aluminum alloys affect casting? Silicon helps with castability. Alloys with high silicon flow better, reduce shrinkage, and improve heat resistance. That's why cast alloys have more silicon than wrought aluminum, which has less than 1%. High silicon alloys are good for complex molds and thin-walled parts. Die casting and sand casting. What's the difference? Die casting uses metal molds and high pressure to create precise parts with smooth surface. Sand casting uses sand molds, which are better for large, complex parts, but less accurate. Die casting is faster and better for high-volume production, while sand casting is cheaper for low-volume or very large parts. Die casting is better for industries like robotics due to its accuracy. Can aluminum die cast parts be heat-treated? Yes, but not all die cast parts respond well to heat treatment. Some alloys, like A360 and A356, can be heat-treated to improve strength. However, alloys like A380 don't benefit much from heat treatment. Heat treatment needs to be carefully controlled to avoid warping or cracking. I hope these points help you understand aluminum die casting better. If you have any questions or need help with project, feel free to contact us.